MCQ 14 is another chemical equilibrium question. Here we have the equilibrium of P plus Q to give us R and 2S. Now the 2 will be quite important for this question later on. So they are either going to be all solutions or they are either all gases, and we're given certain experimental conditions in E1, E2, E3, varying conditions, and PQRS at equilibrium, the amount actually differs. So we're going to use this set of experiment here to determine each of the possible conclusion that can be drawn from that. So the Kc expression that I'll be using is based off the equation will be the concentration of S to the power of 2 times concentration of R divided by concentration of P times concentration of Q. So putting in the values from experiment 1, experiment 2, as well as experiment 3, Kc for experiment 1 will be at 0.0375. Kc for experiment 2 will be at a value of 0.05104. And for experiment 3 is at a value of 0.0375. So for each of the experiment, let's pair them up in terms of variable. So in E1 as well as E2, they both have the same pressure that the experiment is conducted at. However, what did differ was actually the temperature. So E1 was at 300 Kelvin, whereas E2 was conducted at 400 Kelvin. So by Le Chatelier's principle, when there is an increment in temperature, the position of equilibrium shifts to favor the endothermic side of the reaction to absorb excess heat. Now, the area where the position actually shifts to does have an effect on the Kc. So if let's say the position of equilibrium actually favor the forward reaction, meaning the forward reaction was considered to be endothermic, we will generally see an increment in our Kc. However, if it was the reverse reaction, that was the endothermic reaction, equilibrium will shift back, and as a result, Kc will actually plummet. So you can see in the comparison over here that at 400 Kelvin with this elevated temperature, the Kc actually increases to 0.05104 from the value of 0.0375. So this indicated that it was the forward reaction that was the endothermic reaction that we're looking for, and the reverse reaction is actually going to be exothermic. So again, just putting to the front, this is an endothermic reaction. So this aligns with what we want for our answer of C to suggest that the forward reaction is considered to be endothermic.